In the first quarter of 2025, grid-scale batteries in ERCOT earned average annualized revenues of just under $25 per kilowatt. As you can see here, we have the days of the year on the x-axis, with each line showing the revenue made by that point in the year for the past several years. If batteries continue to earn revenues through the rest of 2025 at that same pace, the $25 per kilowatt they earn at year's end will be 55% lower than total BESS revenues in 2024, which is the lowest year on record so far. While the saturation of ancillary service markets has been a huge contributor to this reduction, so too has the increased competitiveness of batteries in offering to provide energy in ERCOT. Average battery capacity offered at discounted competitive prices, defined here as less than $75 per megawatt hour, grew at a faster rate than installed capacity year over year. The average amount of battery capacity offered at competitive prices in any given scout interval grew by more than 300% from Q1 2024 to Q1 2025, from an average of around 600 megawatts to 2.4 gigawatts. While total installed battery capacity also grew rapidly over the same time period, its growth was only around 100%, from 4 gigawatts in Q1 2024 to 8.2 gigawatts by March of 2025. Even more pronounced is the competitiveness of battery offers during the peaks and troughs of daily energy prices. In ERCOT, a battery submits bids to buy and offers to sell energy every 15 minutes of every day. Adding together the bids and offers across the entire ERCOT fleet might look something like this, where the blue area below the x-axis tells us batteries as a whole are bidding to buy as much as 1.2 gigawatts at a positive price in this 15-minute SCADA interval. The light green area above the x-axis tells us that batteries across the system are offering to sell 3.6 gigawatts for prices less than $75 a megawatt hour. Looking at these bid and offer volumes in each interval throughout a day gives us a sense of how the trading operations of batteries in ERCOT affect and respond to energy prices. We see batteries submitted an average of 2 to 2.5 gigawatts of non-negative bids to buy power during some of the lowest price hours of the day in Q1 2025, like 1 a.m. and 9 a.m., pushing minimum prices up. Meanwhile, during peak price hours and peak net load hours, like 7 a.m. and 6 p.m., batteries offer to sell between 3 and 3.7 gigawatts for less than $75 per megawatt hour. This pulls down the highest energy prices of the day. The increased competitiveness of batteries in energy markets played a major role in compressing arbitrage spreads, as average 1-hour real-time price spreads fell 27% year over year from Q1 2024 to Q1 2025. In our full report, we break down some examples of operators that have successfully repositioned themselves to maximize revenue capture under this new style of battery operations. Head to the Modo Energy Terminal or get in touch with a member of the team to learn more. Thanks for watching!